Let's switch over to see if anybody has any questions about the homework. I see question 5 and question 8. All right, here's the Excel spreadsheet. I just copied the problem into here. So store ABC is offering free credit on purchases of over $1,000. You observe that a television can be purchased for nothing down and $4,000 due in 1 year. So I guess that's the free credit. You don't have to pay anything for a year. Sounds like a good deal, huh? Another store offering the same TV, they don't offer free credit, so you have to buy it today. But the price that they're offering is $36.50. So they're offering it for a lower price. So the implication here is that it's really not free credit. Basically, they inflated the price, but then made it so you could delay 1 year in making your payment. So the question is, what statement best describes the real cost of free credit? So the point is it's not really free, and find the implied interest rate, assuming PV, the present value is the price at store XYZ, the $36.50, and the future value is the price at store ABC, which was $4,000 due in 1 year. Okay, so let's go ahead and take a look at that. So let's write all the things down that we know. What's the interest rate? That we don't know, right? That's what we have to find. How many periods do we have? It's due in 1 year, and we're not told about any type of special compounding or anything like that, like monthly or daily or quarterly. Everything's over 1 year. So I'm going to put down just one year, so it's just one period. How about, let's see, do we have any payments to worry about here? Are there any payments that happen period after period after period after period? Now, I know we have one payment at the end, but since it's a single time payment and it's only at the end, we usually put that in as future value, okay? So we're going to say that the payments are 0 in this case. So the next thing is, what's the PV? And we're kind of given in the example that the PV is basically the price that you would pay today. So that's the $36.50. Future value is what we would pay at the first store. That was $4,000. So, so with all these time value of money problems, there's 5 pieces of information. You're usually given 4 of them, and you have to find the last one, right? In this case, we have to find the interest rate. And I'll use the Excel form. I'll do the Excel formula first. And that's going to look something like this, equals, let me make this a little bigger for you guys. Does anybody remember what formula we would use in Excel for this one? Let me see if I can.
You use the rate formula.
Yeah.
Okay, so let's use the rate formula. Okay, and then as soon as we type in the rate formula, I had to click on it a second time. It shows you what information we need down here. Are you guys able to see that? It probably depends on
Yeah,
how big your screen is.
Yeah, we can see it.
Yes.
Yeah, I can see it.
If you're on your phone, good luck. That's a tough one. If you're on a computer screen, you can read it, but basically it gives you a hint on all the information you need to put in using the rate formula. And so the first thing is the number of periods. And so what I'm going to do here, I could type in 1, but if it's okay with you guys, I'm just going to highlight the cell where that, whoops. I'm just going to highlight the cell where that information is, and that'll, it's kind of a nice way of doing it. If you're doing this for your job, that's eventually how you'll do all these. Then we put in the payment, and in this case, that's this cell right here. Golly, come on. And then we're going to put in the present value, which is right here, and then a comma, the future value. Now, I think I put it in, I didn't make any typos, but if we just put it in as is like this, it's going to give us an error. Watch this. This is the numbskull error. No offense intended to anybody. Right here, right? And if you click on it, what does it say? Help with error. It's kind of hard to tell what it's doing, why it's giving you an error. But whenever you have to input values, cash flows that happen present value and in the future, remember how Excel, like if you input a future value that's positive, it gives you a present value that's negative. So Excel and financial calculators, they have to balance these cash flows. So if you're going to get something now, you have to give out something later. If you're going to get a loan now, that's a positive cash flow, money coming to you. You're going to have to give that, you're going to have to make loan payments in the future where you pay that money out. So it balances those positives and negatives. So what it means here is that either the PV or the FV on this problem needs to be negative. So if you're ever calculating a rate and you get this numbskull error, just make sure, just put a negative sign on the present value and it should solve it. So let's go ahead and try that. I'm going to go up here to this PV, put a negative sign, and boom, there it is. Let me increase the, so there's our answer, 9.59%. And so that's the implied interest rate of this free financing.
So what would happen if you didn't really think about it clearly, but you knew one had to be negative, and then you made the future value negative and the present value positive? Would it make the percentage negative?
No. No, Excel's not that smart. Let's try it. It's going to give us the same answer.
Oh, okay.
Yeah. But if we had a problem with payments, then you have to, you have to think about the direction of the cash flows. Is it money that's coming to you, or is it money that's being paid out? And later on, when we do financial analysis of projects and we try to decide what's a good project, what's a bad project, we're going to keep track of those directions of cash flows. Right now, it's, we don't have that complicated of a problem where we have to really do that. But here it's just figuring out how to work with Excel or a financial calculator, and you kind of have to play by its rules of balancing the ins and the outs of cash flows. And it keeps track of ins and outs by the negative sign. So if we were to do the math, right,
Got it. I just wasn't sure, like, if you made a mistake, like, would X put it negative or if it would just make it work still. But I mean, that makes sense because I mean, it's still a different cash flow. Like, you're still putting in money and then
Yeah.
taking out, like, one has to be negative, one has to be positive.
The main thing with these problems is that you're consistent in how you use the negative sign, and whether or not you define a cash flow as positive or negative really isn't that big of a deal. The main thing is to be consistent in how you apply negative signs in terms of how you define which direction a cash flow is going and whether or not that direction is negative. I got a question that says I got 10% in Excel. So basically in Excel, if you, I'm going right up here and I'm changing the number of digits in the answer. And look, if I make it so there's no digits right at the decimal point, Excel changes to 10%. So Excel's rounding. So you have to click on this cell and then increase the number of significant digits up here, if you can see where I'm pointing. And so just go like this. I'm clicking on that, and it increases the number of digits. That one can catch a lot of people. So be careful with that. That's an easy error because the default on your Excel spreadsheet might be just single digits, or like in this case, I think the default was 2 decimal points, right? And since it's a percentage, right, like 10% is already 2 decimal points to the right of 1, right? So 10% is 0.01. So if the automatic answer setting on your Excel is to the 100th, that means percentages will be rounded to a whole number, if that makes sense. So in this case, we just take the present value, I will say this, whenever you do, you're solving for interest rates, when like you're given PV and you're given FV and you have to solve the interest rate, this is where using the Excel formula really does make it a whole heck of a lot easier. This one is relatively simple because it's only one period. So this formula right here that I'm highlighting, right? Basically, we're solving for R if we're going to do the math. And it's not too bad because we're only taking it to the power of t equals 1. So the algebra is going to be fairly simple. But once we start going to multiple cash flows and higher values of t, it gets a little more, the degree of difficulty just goes up a little. And at some point, you won't even be able to do it with math because it'll turn into a problem where even Excel, what they do is they use an iterative technique to solve for interest rates, where they guess a number and then they guess another number and they try to make both sides of the equation balance by just guessing numbers. And once they get them to balance enough, then they say that's the answer. So we can solve this problem right now using math for the interest rate, but I just want to give you a heads up that if you prefer doing the math, when it comes time to calculating interest rates, some of the problems are not going to be solvable with math, okay? At least not in the time you have, because it could take a long time to guess. So in this case, right, we'd have to do some algebra, basically, and solve for R. I don't know if it's, so basically we have 3650. So this is our formula, and we basically have to solve for R, right? I'm going to multiply both sides by 1 plus R, just to, and you know 1 plus R to the 1 power is just 1 plus R, right? So that's why I'm kind of simplifying things a little here. So that gives us that problem, right? We multiply both sides by 1 plus R. And over here, this is this 1 plus R is a denominator. And then we multiplied it by 1 plus R on the outside of these brackets. So that means we're going to get this. Okay. And that means we're left with this then if we divide both sides by 3650. Right? And so that means R is equal to 4,000 divided by 3650 minus 1. Okay, so I'm guessing that's going to be around 9.589%. If someone wants to confirm that with the math, that's wonderful. But I'm pretty sure that's what it's going to be. So that is number 5. Any other, did I answer everything on there, or is there any other question? My guess is the key there is to put the negative sign on like present value, and then the Excel formula will work. That's probably what, I'm guessing that may have been the issue you had. All right, looks good. Let's go ahead and do question 8. All right, here's the question. What's the present value of a 5-period annuity of $3,000 if the interest rate is 12% and the first payment is in 1 period? So let's go down here. What is the rate? So the rate in this case is going to be 0.12, and it looks like it's basically for the period, and we're not really given the period, but 12% is the rate per period because we're not given enough information to tell otherwise. The number of periods in this case is 5. The present value, we don't know that. That's what we have to solve for, right? The future value, is there a lump sum payment at the very end on this? I don't think there is, right? It's just the annuity. So that means future value is going to be 0. And so the last thing we have to figure out, what is the payment? And that's going to be $3,000 every period. That's kind of the definition of an annuity. And the fact that the first payment is in one period just shows you that it's following the definition we have of an annuity. Okay, so the first thing is we have to put in the rate, and so that's 0.12, then a comma, and we put in the number of periods. That's that one, then a comma, and then we put in the payments that we make, and then another comma, and then we put in the future value. Okay? And so that should be our answer. If we hit enter, we should get the right solution then. So I got 10,814. And that's how we solved it again. Let's do it the math way. In the math one, we had that annuity formula. It was one of the bigger formulas we have, and it started. It was something like this. So first, C represented the periodic cash flow, the payment you have every single period, and then you had to multiply it by 1 over R. And then you had to subtract this really big term. It was, boy, let me think again. It was 1 over R times the quantity 1 plus R all to the power of T. So that's basically the annuity formula, and that's what helps you, you're able to calculate the PV then, given that formula, okay? So I'm going to go ahead and do that in the math here. So it's equals, then here's the payment, right? And then we have a parenthesis, and we have 1 over R. Here's R. And so that's the first part. And then for the next part, it's 1 over, and then we're going to have some more parentheses. And you know, I forgot a multiplication sign here. There we go. That star is for multiplying, right? And then the rate again and then multiply by 1 plus the rate again, all to the power of the number of periods. And that should give us the exact same answer. We just program the math into Excel. Let's see what happens. I think it got rid of some spaces that I put in. That's all it looks like it did. Yep, 10, 8, 14. And there's the problem. It took out all those spaces that I was putting in to make it more readable. That's all it changed. Any questions on number 8 in the homework? No? Were any other problems that somebody would like to review from the homework?
Number 11.
Number 11. All right, so what is the effective annual rate for a 12% APR, assuming monthly compounding? Does anybody remember the formula for effective annual rate?
1 plus periodic rate to the power of the number of periods per year minus 1.
So something like that, right? And we could, if you wanted, we could do this just to make it more clear, because those exponents can mess people up sometimes. So kind of like that, I think. So 1 plus the periodic rate, that whole quantity to the power of the number of periods, then that whole quantity minus 1. Okay, so that's our formula. So what's the periodic rate? So the quick way to get the periodic rate is to take the APR and divide it by the number of periods per year. Okay? So that's 0.12. And how many months are there in a year?
12.
9.
Wait, what? Is that the lunar year? I'm gonna go with 12, all right? So that's the interest rate per month. Where did this come from? It came from this. Okay? And so you can do some, if we divide both sides by the periods per year, we get APR divided by periods per year. Right, so this right here, the periodic rate equals the APR divided the periods per year. That's what I did right here. 0.12 is the APR, and 12 is the periods per year. Okay. Any questions on that so far? Then we take 1 plus the periodic rate that we just calculated up here, 0.01, and we take that to the number of periods, the total number of periods in a year, and in this case it's 12. And that should give us our answer. Okay. Any questions on that? Okay.
Can you click on that formula again? I just want to see how you do. Thank you.
Mm-hmm.